this section I'm going to cover the hardware side of the dome automation control system, and I just want to show you the physical side of things before I go into any details at all of the electronics and how it all connects together. So as I've mentioned before, I've taken the lid off the main control box here, and I'll just show you what's in there. It's actually very simple. It's not complicated at all. A 24 volt supply, power supply, that's powerful enough to power the motors, and then a little device here that feeds, takes the 24 volts and creates a 5 volt output for the Raspberry Pi, which is here. And then the other main thing is these two cards here. These are little PWM motor controller drivers, and I think I've mentioned they were only about £11 each, so they're not expensive, and it would be, you'd never make one as cheaply as you can buy these, and they're very, very good indeed, very reliable. So the Raspberry Pi has got inbuilt wireless, and it needs to connect onto the network, as I'll explain. I've actually got a LAN connector here because I've got a little switch just across the way there, and the other connections are that the GPIO port, the general purpose input output port with the Raspberry Pi, which is the sort of hub of the whole thing if you like, several wires connecting to the PWM controller, and also wires coming in from these two connectors, a simple one here for the little magnetic home switch, and another one here which takes the inputs from the opto sensors for the positioning system. So I'll explain the circuits of that shortly, but let me just go back over to remind you, here's the opto sensor. There are 4 of those little devices in there detecting the positions of the mirrors. Now what I decided to do was the wires from those, I decided to build in a little simple circuit. I'll explain this circuit. I built this little circuit, or I designed it and had it made. It's very cheap to have circuit boards made these days on the internet. And the inputs come in here, and this board deals with just the sort of resistors and things like that, and also it takes 24 volts and it creates the 5 volts and the 3.3 volts that are needed for the devices. So a very simple wire comes in and goes to the Raspberry Pi, and so on the Raspberry Pi box there's not many things. There's a LAN output, as I say, the 2 connectors, the 2 outputs to drive the motors, and the other thing is just a simple mains feed for the whole box. Okay, so that's the hardware layout of the driving system and the sensoring system. So I'll move on to explaining how that all connects together. In that last segment, you saw inside the various control boxes and the various bits and pieces inside that make up the control system. So I need to drill down in a little bit more detail, and to do this I'm going to show you this functional system diagram where I can drill down into a little bit more detail about the various bits and pieces, and also some very basic electronic circuits that are used to hook the whole thing together. So starting here with this blue box at the bottom, this is the main control box that you've seen inside the dome on the wall. Now in there is a 24 volt power supply that should be powerful enough to drive your DC motors. And also, of course, the Raspberry Pi itself, the single board microcontroller, which is the center of everything really. So let's look at that in a little bit more detail. As you can see, it's got USB ports, it's got local area network connection ports, it's got inbuilt wireless and various other ports, which we're not particularly interested in. But the main thing we are interested in is this GPIO bus, general purpose input output pins or port. And those pins can be programmed by your software that will be running on here to make some of the pins do various things. Certain pins can become inputs to read values, they can become outputs to set things on and off, and they can also have specialized functions such as PWM motor control, and that's exactly what I use to drive the motors. Now, the Raspberry Pi itself does not have enough current ability to directly power the DC motors. So in between the motor and the Raspberry Pi, we have an H-bridge motor driver, which you saw inside the box in that last segment. These are very cheap, about £11 each in the case of the ones that I'm using, and they're very, very good. And if you like, those are amplifiers. So there's a connection between the GPIO into this little device and then a connection directly to the motor. Now, PWM stands for pulse width modulation, and that's easily explained if you look at this diagram here. If you were just to wire a hard 24 volts to the motor, it would just go at full speed. And if you were to reverse the connections, it would go backwards the same full speed. But if you power with a square wave like this, and you modulate with a pulse, you can control the speed of the motor very effectively indeed. It's much better than just reducing the voltage. The motor keeps its power and it keeps its efficiency. So it's a very good technique. So the top trace is indicating a 50% on, 50% off. And this would be typically about 5 kilohertz, this frequency. And that would run the motor at half speed. The middle trace would run the motor faster at about 3/4 speed, and the bottom trace would run the motor slower at about 1/4 speed. So that's what the PWM is all about. Moving on to the position sensing side, as I've mentioned, the GPIO, you can program the pins to become inputs, and that's what is done in the case of the 4 position sensors. They just, I'll show you how the circuit works, but effectively there's a wire going into, for each of the sensors, into each of 4 pins, which read the state of the sensors. And of course, one sensor should only be firing at any one time because of the reasons I showed you with the mirrors earlier on. And likewise, another input pin is used for the magnetic read switch to read whether or not the dome is at the home position or not. In this diagram, you can see the layout of the 4 infrared photodetector devices, and the strip, the black strip with the 2 grey squares, is meant to indicate the mirrors as they go past the devices, which are in that rather Heath Robinson looking wooden device in my dome. And these little pictures here, they actually come from, as you'll see later, they look like this. And so the E is the emitter and the S is the sensor. So you need to connect wires to these things, and I'll explain how to do that. But as you can see, in this case, number 1 is firing and the others are not. And let's say it was moving from left to right. The mirror would go to number 2, number 3, number 4, and then another mirror would come along behind it and it would fire on number 1 again. So that's how it works. Here's a quick view of the data sheet of the little photosensitive devices. QRB 1113 or 4. I don't actually know the difference between the two. I think I've got 1114s. And they're available for about £1.50 at the moment. I just looked them up. So very, very low cost. And as you can see, there is, between pins 1 and 2, there is the little the little photodiode that projects the infrared out. This is the mirror, indicated by the mirror here on this schematic. And then there is the little photo transistor between pins 3 and 4. And what happens is the photodiode is on the whole time. So you bias it on, and so it's not switched, in other words, and so it's always emitting infrared light, but only when a reflective surface comes in the way does it reflect back and effectively causes a base current to flow in this little transistor, which turns it on. So that's how these devices work. And this is the extremely simple circuit diagram that I have arranged in my system. Again, showing you the little device here. I think I'm missing a 1 there. It should be 1114. But as I say, between what you have is 5 volts, a 220 ohm resistor running down to ground. That causes this little photodiode to be on all the time, and it causes it just to have exactly the right current to make it shine at the right level. And then you need to connect the transistor to your Raspberry Pi input. And there's 4 of these devices, so there'll be 4 wires going to 4 different inputs. And this is the very simple circuit where you need 3.3 volts for a Raspberry Pi input. If you want to switch an input to high, 3.3, low, ground. And this is how you would arrange the biasing with these 2 very simple little resistors. And when the device is switched on, current flows and the input is triggered, and you write software to detect that. This is the little circuit diagram of that little interface box that I elected to put in between the photodiode array and the Raspberry Pi main control box. And this is because it was getting too complicated inside the main box to arrange for all these little resistors and voltages, etc., to be in the right place. So I decided to, you could put this board inside the main control box, whatever you wanted to do, but I found it more convenient to have it outside. So what happens is 24 volts and ground comes in from the main control box, and I put these little voltage regulators in, a 5 volt voltage regulator and then a 3.3 volt voltage regulator. Very, very cheap and cheerful little components. A couple of capacitors, and this generates the 5 volts and the 3.3 volts that's needed in that previous circuit diagram. And then I've just arranged for all the 220 ohm resistors, the 1K and the 10K resistors to all connect to these little connectors which you saw inside that box. And that just makes the whole thing a lot easier. Now, I designed this little circuit using some a little tool on the internet, and then had the boards made for a couple of dollars each, and they only take a few days to come. It's remarkable now what you can do if you want to have a circuit board made. That concludes this video about the electronic hardware, and the next video will be about the software. So I'll leave you now with this image that was taken with the telescope in the dome just a few weeks ago, and this is the Galaxy M106.